So the problems we were looking at today were either in factored form, such as this problem, or they were in standard form, such as this problem. So we talked about two different ways to solve them and find the vertex. So for solutions, if you're in factored form, you're trying to figure out which value of x will make this equal 0. So I know if I set x plus 3 equal to 0, I would get x is negative 3. If I were to set up this set of parentheses to be equal to 0, I know that x would be 1. So these two are my solutions. So we talked about them being called solutions, we talked about them being called zeros, we talked about them being the x-intercepts, as well as a new one which are called roots. So this is how we would find the x-intercepts. In order to find the vertex from this, I know that my vertex has an x value that's going to be in the middle of my two x-intercepts. So if I add my two x-intercepts and divide by 2, I'll get, in this case, negative 2 divided by 2, which is negative 1. So that tells me that the x value for my vertex is negative 1, and then I plug in negative 1 into the problem and I simplify. So when I do that, I would get 2 times negative 2, which is negative 4, so my vertex is at 1, negative 4. And that's how we can find both of the solutions and the vertex from factored form. To do a problem like this one that is in standard form, we talked about using our axis of symmetry, which is negative b over 2a, and we know that our x-intercepts are either going to be to the right or to the left of this line, so it's going to be the same fraction. And the way we figure that out is using this top part, which is the new piece we talked about today, which is b squared minus 4ac. And altogether, this is the quadratic formula. So with our quadratic formula, we have our axis of symmetry, and then how far to the left or right we go from the axis of symmetry, and that's how we're going to be able to find our solutions, our roots, our zeros. So if we come and take a look at our problem, so we can see, if we're using our formula here on the side, we can see that our a value is 1, our b value is negative 2, and our c value is positive 2. So using the quadratic formula is just a matter of plugging in our values. So we're going to take the opposite of negative 2 over 2 times a, plus or minus my b value is negative 2 squared minus 4 times a times c, and our denominator would be the same, 2 times 1. Now, when you're working on these problems, the first few, I would suggest you simply replace the values like we just did here. As you get going, you can recognize that you can do some of this simplification as you're going through. 2 times 1, you don't need to write 2 times 1 because you know what 2 times 1 is. So as we go through and do this, this would give us 4 minus 8. And so here we can erase a little bit. That's going to erase too much, but we'll shorten it up. So this would be x is equal to 2 over 2, which is 1. And this would be the square root of negative 4 over 2. Now, something you want to pay attention to is this piece right here. If that number underneath there, if this number is, that's a bad color to write in, let's try this. If that number is less than 0, that tells me that there is no real solution. And what that means if we are looking at this on a graph, what that is telling me is that it doesn't hit the x-axis. So just as a quick sketch of this graph, if we had a quick sketch of this, so looking at our original a value, we see a is positive, so we know that this graph on our axis of symmetry here is 1. So we know that this graph is going to open upward, but you can see that it doesn't hit the x-axis. So that's why we have no real solution. So we will continue to work on these problems throughout the week, and making sure that you are well aware and capable of using the quadratic formula.